If you've ever played the game Minecraft, there's a pretty good chance you've gone mining for diamonds. If you don't know, diamonds are the most valuable material in Minecraft. A huge goal in the game is to obtain as many diamonds as possible. So let's find out the best mining method for obtaining them. There are a bunch of caves around the Minecraft world that can take you deep underground to find resources. But early on, players found out that caves weren't too safe. So strip mining was created. Just dig yourself down and mine in a straight line. Hopefully, you'll come across some diamonds on your path. Unfortunately, diamonds are extremely rare. For starters, they only spawn between Y levels 1 and 15. If you don't know what a Y level is, it's actually really simple. Think of the Minecraft world like an XYZ coordinate grid. One block equaling one coordinate. The X changes if you go one direction, the Z changes for the other, and the Y changes if you go up and down. A player's Y level is measured by the location of the player's feet, and the player is 2 blocks tall. Using this information, we can see the diamond distribution on all relevant Y levels. It might seem like mining around Y level 6 is the best, since there are the most diamonds there, but that level is dangerous, with lots of lava lakes that can easily kill you. Since this is unnecessary added danger, I will mine at Y level 11, since the lava lakes are only at Y level 10 and down. Overall, it shouldn't matter what Y level I mine at, as long as I stay consistent. Most people mine at Y level 11, so that's what I'll do. Now it's time to find what method is the best for mining diamonds. The reason that it's difficult to figure out the best method is because of this. Each time you mine a block, it exposes other blocks, which could potentially be diamonds. Different methods can expose a different amount of blocks. I'll explain this more as I explain each method. The first method, method A, is 2x1 normal strip mining. This is just a straight path, mining only the blocks you need to walk forward. Each block you mine in this path reveals 3 other blocks where diamonds may be. Method B is very similar, except you use a glitch to push yourself down so that your character takes up only a 1x1 space. So now each block you mine exposes 4 other blocks. The next method, method C, is similar to the 2x1 method. There's something called branch mining, where you create additional short paths on each side of the original path every 3 blocks, like this. The last method, method D, is also branch mining, but for the 1x1 path. Also, just a note, if I come across a cave as I'm mining, and I see diamonds not on my path, I won't collect them, since I am counting the amount I come across on my path and not if I randomly come across a cave and find some. Now that you've got a good understanding, let's get to the trials. I will conduct 5 20-minute mining sessions for each of the 4 methods, and then compare the data. I'm using a matched pair design where I am my own matched pair. The explanatory variable is the method, and the response variable is the amount of veins or groups of diamonds, and the overall amount of diamonds. Since diamonds come in clusters from 1 to 8, counting the amount of them adds extra variability, so looking at the veins is the most reliable. The Minecraft world is very big, with a border forming at about 30 million blocks out in all directions from 0, 0. Since I have 20 trials, I randomly generated 40 numbers from negative 29,999,983 to 29,999,983 for 20 sets of coordinates for the locations of each trial. One number is the X coordinate, the other is the Z coordinate, and obviously 11 is the Y coordinate. Then, I randomly assigned each of the 20 locations a number from 1 to 20 with no repeats. I also randomly generated numbers from 1 to 20 with no repeats for each of the 20 trials to match them with a location. Alright, let's get to the trials. I was both of the parties in this study, so obviously there was no blinding involved. As you can see, this is method A. I got a total of 13 veins and 79 diamonds. In method B, I got a very similar amount as method A, also 13 veins but 82 diamonds. Method C was also similar and got me 11 veins and 57 diamonds, and method D I got 13 veins and 70 diamonds. By these graphs of the data, it seems as if the method used does not seem to matter too much. First, I'm going to assume that all the methods are the same. To test this, I'm going to do something called a goodness of fit test. We'll learn about this later, but all you need to know for now is that after putting in my total amount of diamonds for each method, I can find a p-value. my data, my p-value is 0.968. If the p-value is greater than 0.05, then there is not strong evidence that the methods are not the same. Since my p-value was very high, I am fairly confident in saying that all 4 methods are equally likely in obtaining diamonds. It was interesting that in method B, there was a trial with 40 diamonds, but since it balanced out in the end, I speculate that was just lucky random chance. To be more certain with this experiment, it would obviously be better to conduct more trials, but since that is not very practical, I am content with the data that was collected. As for limitations, I don't really think there were many, mostly because I didn't have to deal with other people. I was very conscientious throughout the whole experiment. During the trials, I always made sure to have no distractions and giving my full concentration for 20 minutes. I also spread the trials over multiple days, so no exhaustion occurred. With all of the randomness I used, I just cannot find any bias that could have occurred. To be sure of this, if this study was to be done again, it may be better to get multiple people to perform all the trials to compare them and see if there were any drastic differences. Although I hoped to find one method that was exceedingly better than the others, I didn't. I would probably recommend method A, just because it requires the least effort with no turning or glitching involved. But if someone likes another method better, based on my data, they should use the one they prefer.